Hello, I'm Dr. Maya Dunne. This video, I'm going to show you in chapter 1 what are the things you need to focus when you study chapter 1. In chapter 1, first you need to know what is matter. Matter is, and then you need to know how you're going to classify matter. We classify matter according to two methods, according to its state, solid, liquid, gas, and according to its composition. And once you classify matter, you need to know about the chemical symbols. We learn in detail about the chemical symbols in periodic table, but right now you need to know common chemical symbols like C for carbon, H for hydrogen, Al for aluminum, basic things you need to familiar. If you know periodic table, you know there are main group elements, D block like represent the main group elements and transition elements. At least try to familiar with main group elements now. But when we do the periodic table, you need to familiar with all the symbols in the periodic table. So if you have time, now it's a good time to familiar with the what is the symbol and what is the name. Example, what is Ag? It's silver. What is Au? It's gold. So it's now you have time, because otherwise in the exam, when it comes to close to exam 2, you don't have enough time to familiar with all the elements in the periodic table. So take the periodic table with the symbol and the name on it. Try to be familiar with these symbols, because in the exam, I am not giving you the name. I am giving ask question. In the question, I am giving you the symbol. So at that time, you need to know what is that element is. So it's a good time to familiar with the symbols, chemical symbols in the periodic table. So after that, you need to know about compounds. What is a compound? What is an element? You need to know the difference. What is a compound and what is an element? And we do one law, which is law of constant composition, law of definite proportions. And then we try to classify mixtures in two types, homogeneous, heterogeneous mixture in this chapter. And we also talk about types of properties. We talk about chemical properties, physical properties, intensive properties, and extensive properties as well. And then changes. There are two types of changes we are learning: chemical change, physical change, and also another important techniques we are learning in this chapter 1 is separating techniques. How to separate a mixture. There are many techniques to separate mixture, but in this chapter, you need to familiar what is the filtration technique, what is distillation, what is chromatography. And then types of energies, kinetic energy, what is kinetic energy, which is associated with the motion, and potential energy. And the last part of the chapter 1 consists of numbers. Very important. Numbers play important role in chemistry. Units. We use two types of SI units, metric units, quantities, uncertainty of the measurement, accuracy. You need to know what is accuracy, what is precision, significant figures, rules for assigning significant figures, and also another thing, scientific notation, how to write, how to give answer in scientific notation. And the last part is dimensional analysis. So these are the important topics you need to follow when you study chapter 1. So these are the topics I'm planning to cover in chapter 1. You will have questions in the homework as well as in the critical thinking questions. Okay, in chapter 1, at the beginning, we learn what is matter. What is matter? Matter is anything that take up space and that has a mass. So that is matter. So anything that has a space and has a space and it has a mass. So basically it takes up space, okay? It takes space and has a mass is matter. Everything you see around us is matter. So the next, so if you think about oxygen, it's matter. If you think about your book, that's also a matter because it has a space and it has a mass, right? So now in the next part, what we're gonna do is we're gonna classify this matter. We can classify matter according to its state and according to its composition. Let's see how we classify matter according to its state. What are the three states of matter? Solid, liquid, gas. Solid, liquid, gas is three states of matter. So matter can classify according to its state. If you classify matter according to its state, that is solid, liquid, and gas. Okay, solid, liquid, and gas. These are the three states of matter. And then you can again classify matter according to its composition. According to its composition. Let's see how you're going to classify matter according to its composition. Matter can classify according to its composition into a mixture and also a pure substance. So in this slide, you'll see matter classify according to its pure substance and a mixture. Mixture, you can classify homogeneous mixture, heterogeneous mixture, and pure substance can classify according to it element and compound. So we see matter classify according to its composition into pure substance, mixture, two types, homogeneous, heterogeneous, pure substance, element, and compound. Okay, so let's look at examples for each. What is an element? Element is any substance that cannot break down into any simpler substances. If you think about helium balloon, helium is an element. Can you give me another element? Anything in the periodic table, we call periodic table of elements. Anything from the periodic table is an element. Carbon, gold, platinum, silver, anything is an element. Compound. Compound is anything that can made out of more than one element. H2O is a compound. It's a pure substance, right? If you take pure water, it's a pure substance, but you can break down into hydrogen and oxygen. So that is a compound. Mixtures, two types, homogeneous, heterogeneous. Homogeneous mixture is a mixture that made out of more than two compounds or elements, but you see it as a uniform. It's a uniform substance. A good example is sweet tea. You don't see a separate compounds in sweet tea. And if you dissolve sugar water, it's homogeneous mixture. Air, homogeneous mixture, and blood also homogeneous mixture. What about heterogeneous? You can separate its individual components. That is heterogeneous mixture. Good example is chicken soup. You can separate pieces. So that is the example for homogeneous mixture, heterogeneous mixture. And now we are moving to our next part. Representing chemicals. Representing chemicals, you need these elements in order to represent the elements. The symbols, knowing chemical symbols is very important. If you see this slide, I have listed very important chemicals in the periodic table. You need to know the chemical name and the chemical symbol. Chemical symbol is a universal system that you can use to identify these elements. So always keep in mind some symbols, there's only one letter such as carbon, but there are some elements, two letters. Always first letter is capitalized, the second letter is lowercase. And we are learning another important thing, which is law of constant composition. Constant composition. definite proportion, what is this law of constant composition or law of definite proportion? Let's see what is this law describes. Law of definite proportion or constant composition gives that the relative number of each element in the compound is same in any sample. What that means? That the relative number of atoms of each element in the compound is same in any sample. Let's take water as an example. H2O. H2O is the chemical symbol for water. In H2O, you take water in the campus. The composition is H2O. You take water, which is H2O, in another state, which is the same chemical composition. That means if you take any sample, any compound, the chemical composition is same. In H2O sample, you have 2 hydrogen molecules to 1 oxygen molecule. That is law of constant composition or law of definite proportions. Now we are discussing the types of properties. There are mainly 2 types of properties, which is physical property, chemical property, and also I'm going to discuss intensive property, extensive property. What is physical property? Physical property is a property that you can observe without changing that substance into another substance. That is physical property. Example for a physical property: boiling point, melting point, mass. So those are the physical properties. But if you think about chemical property, in order to observe chemical property, the substance change into another substance. So example for physical property, if you see this slide, you can observe without changing to another substance. Actually, it's melting point, boiling point, hardness, color, order, density. But if you think about chemical property, it is observed when substance change into another substance, flammability. So those are the chemical properties and physical properties. And now I'm going to discuss 2 other properties, which is extensive property and intensive property. Intensive property, they are independent of the amount of substance that is present, which is its property of that material itself. Density, boiling point, and color. That means density, if you take 100 grams think about density of iron. Density of iron in 100 grams of iron is same, right? It does, if you take 100 grams, if you take 1 kilogram, density is same. Similarly, water. So density is intensive property. It's independent of the amount of substance. Extensive property is depend on the amount of substance present. So those are the 4 different types of properties that we discussed. And then I'm going to talk about physical changes, chemical changes, 2 types of changes. These 2 types of changes, physical change, that is, example, physical change, that is, it doesn't change the composition of a substance. Example, change in the state. What is the change in the state? Ice melted to liquid water. That is, liquid. So ice means solid state, go to a liquid state. Change in temperature. Water, you boil water. The temperature of water is 30, it goes up to 100. But it doesn't change water, it's still water. Those are the physical changes. Chemical changes, flammability, combustion, oxidation. Combustion is burning, oxidation, corrosion of iron, and decomposition. Those are the chemical changes. So in this section, we talk about properties, chemical properties, physical properties, and then intensive properties, which is independent of amount of substance. Extensive properties depend on the amount of substance. And then we talk about 2 types of changes, physical change, chemical change. So in this section, we are talking about separating mixtures. In separating mixtures, there are many methods we can use to separate mixtures. But in chapter 1, I'm discussing 3 basic techniques that use to separate mixtures, which is filtration, distillation and chromatography. Separation, it's based on physical properties, not on chemical properties. You don't need to change the identity of the substance in separating mixtures. Filtration, distillation, chromatography. Filtration is the basic techniques that showing in this slide. You use the funnel and then filter paper. Using gravity filtration, you can separate solid from a liquid. That is filtration. Distillation is important technique which use the difference in boiling points. Example, in the labs we get solvents, but these solvents they're not pure. In order to purify, you can use their boiling points to separate this solution. So this is distillation. The next technique is chromatography. Chromatography is separation technique that based on the polarity of the different substances. Let me discuss a little bit more about chromatography. In chromatography, there is a mobile phase, stationary phase. In this diagram, I am showing you column chromatography technique. You can fill the column with the stationary phase. We usually use silica gel to fill the columns, and then you pass the mobile phase through the column. That can be liquid, it can be methanol, it can be acetone. You pass your liquid and then you introduce your substance that you need to separate. Think about you want to identify pigments in spinach. You introduce it to the top of the column, and then along with when you pass the mobile phase, it separates according to its polarity. That is chromatography technique. And that is the end of the 3 separation techniques. With separation techniques, then we are moving to the energy. What is energy? Energy is capacity to do work. Work is the energy that transferred when a force exert an object causes displacement of the object. Example, you walk to some distance, that is work. And you run, that is work. In order to do work, you need to have energy. And what is heat? Heat is the form of energy. Then we have thermochemistry chapter, we talk about everything about heat. That is energy used to cause temperature change. That is heat is energy, but is always associated with temperature change. There are 2 fundamental types of energies: kinetic energy, potential energy. Always you can calculate kinetic energy using this equation: half mv squared. M is mass, v is velocity. Kinetic energy always associate with the motion. You do cycling, you have kinetic energy. You start walking, you run, you have kinetic energy. Potential energy, it's due to the position. You sit in the classroom, you have potential energy. As soon as you walk out from the classroom, you have kinetic energy. And now we are moving to the last part in this chapter, which is numbers in chemistry. Numbers in chemistry play a very important role. Math is very important in chemistry. So some students say chemistry is difficult. It's not chemistry. Most of the students struggle with math. So if you're good in math, that's very I thought I'm going to introduce some math concept at the beginning of this chemistry course, so you need to follow these concepts. Main concepts of numbers in chemistry, you need to know the units. Always when you give an answer, you just can't give the number. That doesn't make any sense. Always make sure you write the units. Example, you measure a length. Is it centimeters? Is it meters? You get some weight. Is it in grams? Is it in milligrams? Is it in kilograms? It's like that. And then quantities. And then uncertainty of the measurement. Significant figures. There are rules to assign significant figures. And at the end, we learn dimensional analysis. What is dimensional analysis? Example, I'm saying, okay, my weight is 60 kilograms. Can you express in lbs? So that is the dimensional analysis, converting units. Okay, now let's look at the units. Units, there are 2 types. SI units and metric units. So this is here I'm showing you SI units. If length, it is meters, mass, kilograms, temperature, Kelvin, time, seconds, amount of substance, mole, electric current, ampere, luminous intensity, it is candela. And this is the metric unit. You need to know the difference between SI units, metric units. In the exam, I can ask, what is the SI unit for mass? What is the metric unit for mass? So you need to know the difference in SI units and also metric units. And also temperature, you need to know how to convert Celsius to Kelvin. How do you convert Celsius to Kelvin? You always add 273 degrees to Celsius and then it convert to Kelvin. Example, I'm giving, okay, I have 30 Celsius. Celsius, the temperature is 30. Can you express in Kelvin? You add 30 Celsius to 273 and then you give the answer. So 30 Celsius in Kelvin is 30 Celsius, you add 30 to 273, 303, right? 303 Kelvin. So that is the Kelvin temperature. So that is the, so please familiar with the temperature, these measurements. And then you need to know what is density. Density is mass divided by volume. Density is intensive property, it's a physical property and also it's intensive property. And then uncertainty of the measurement, familiar with that. And another important thing we are coming, which is accuracy versus precision. What is precision? Precision is how close the individual measurement agree with one another. Example, I'm in this slide, I'm showing you a target, how close you are to the target, which is the precision. How close you are all the measurements. Example, you may weigh 10 grams of a wooden block. So the 10 gram of a wooden block, I ask you to measure and one student give me the values, okay, it is 9.81, 9.8125, 9.8826. And then another student tell me, okay, it's 10.1, 10.2, 9.98. In that way, how repetitive the measurements, that is precision. Accuracy, how close the measured value to the actual value, that is accuracy. Significant figures, next part, significant figures important. You need to know the rules to assign significant figures. The rules for assigning significant figures, all non-zero digits significant. If it is a non-zero, if it's definitely a significant figure. Zeros between non-zero digits, they are significant. Zeros at the beginning of the number, never significant. Zeros at the end of the number, significant. So please familiar with the significant figures. In the exam, I can give you example, I can give you, okay, 504. How many significant figures? 3 significant, right? 504, 3 significant figures. If I ask, okay, 5,000. How many significant figures? 1 significant figure. So please familiar with those rules for significant figures. And then the dimensional analysis. I think with that, I'm finishing the chapter 1. And you can do the homework and the critical thinking questions. Thank you.